Dogs are amazing at reading our faces, but how do their brains actually process those expressions? Do they understand specific emotions, or just sort our moods into generic good or bad? Imagine a dog watching its owner show sudden fear versus quiet sadness. To find out if dogs know the difference, scientists put awake dogs into MRI machines and scanned their brain activity while showing them pictures of human faces. When the dogs saw happy faces, a specific reward and cognition center in the brain lit up brightly. But negative expressions were the real mystery. If a dog saw anger, fear, or sadness, would the brain just trigger the exact same general warning signal for bad? A whole brain analysis revealed the answer is no. The canine brain generates completely distinct, separate patterns of activity, proving they can physically distinguish fear from anger and sadness. This highly specific neural mapping developed through thousands of years of domestication, allowing dogs to deeply cooperate with us. So when that pet dog sees its quietly sad owner, its brain doesn't see a generic threat. It fires a unique, customized pattern specifically for their sadness. Archaeologists just proved that ancient Greek elites wore rings forged from shooting stars. Because before humans learned to smelt iron, the only source of the metal was space rocks. Take this 3,000-year-old iron ring found inside a Mycenaean tomb. Traditional chemical testing would physically destroy the rare artifact, but modern handheld X-ray scanners read the metal's chemistry without making a scratch. This ring revealed a unique fingerprint, naturally high levels of nickel. That nickel spike is the definitive signature of meteoritic iron. Greece's wet climate rapidly rusts and destroys fallen meteorites, so this raw space metal had to be imported from arid trade partners like Egypt. Because it couldn't be mined, this iron was mounted alongside gold and silver, becoming the ultimate symbol of power for nobles. But once humans mastered iron smelting in the 12th century BCE, iron shifted from a cosmic jewel to a common tool, ending the meteorite ring era. And that heavily rusted Mycenaean tomb ring that sparked this entire investigation, it stands as the definitive chemical proof that these ancient elites literally wore the stars. How does a light-devouring void disguise itself as a shining star? Enter the black hole star. For decades, astronomers wondered how early supermassive black holes grew so huge, so fast. The answer hides inside mysterious little red dots, discovered glowing just 660 million years after the Big Bang. Look inside one of these red dots, and you'll find a tiny early black hole eating matter at extreme speeds. As it feeds, it pulls in a turbulent, incredibly thick cloud of gas that completely wraps around it. Typical black holes form a flat accretion disk, but here the gas is so thick it forms a massive shell 100,000 times larger than our sun. The intense energy from the feeding black hole superheats this dense envelope until the outer layer begins radiating its own light, mimicking the surface of a giant star. This light scatters through the gas and shifts into the red spectrum. It perfectly hides the rapidly growing void deep inside. So that mysterious little red dot astronomers found glowing at the dawn of time, it's just the perfect disguise for a baby quasar, safely eating its way to the center of a future galaxy. The newly discovered hydrogenobody is the secret engine behind cow methane emissions. It's a massive puzzle because livestock burps drive 30% of rising global temperatures. To see how it works, picture a massive predatory microbe swimming deep inside a cow's stomach. This giant cell uses thousands of sweeping hairs to pull in and devour smaller bacteria. But powering those hairs takes energy, which creates a strict biochemical balancing act. The internal process produces toxic excess hydrogen gas, and the cell's engine will shut down if any oxygen is present. The solution? A specialized membrane-wrapped pocket at the base of its sweeping hairs. It acts like an exhaust pipe, pumping out hydrogen while consuming stray oxygen. This is the hydrogenobody. This steady exhaust stream attracts opportunistic microbes called methanogens. They gather on the outside of the cell membrane, right next to the hydrogenobodies. Thriving in the oxygen-free zone, they feast on the pumped hydrogen and excrete their own waste, a bubble of methane that floats upward. So for this one tiny predator, the hydrogenobody simply keeps it alive and hunting. But multiply this microscopic gas exchange by trillions of times across an entire herd of cattle, and all those invisible bubbles rise up to shape the atmosphere of our entire planet. Brain disorders are the leading cause of illness worldwide. But the Planetary Health Diet actively slows cognitive decline. So how does a change in food actually protect your mind? Take a standard meal from this diet, a bowl of whole grains and vegetables being digested. This plant-heavy meal delivers a massive payload of protective compounds into your digestive tract, specifically dense clusters of antioxidants and polyphenols. But there is a physical gap. These protective compounds are trapped down in your gut, while the organ they need to protect is locked far away inside your skull. Your gut microbiome solves this distance problem. The bacteria break down the plant compounds, altering indirect immune pathways in your bloodstream. These modified immune signals travel straight upward to the brain, where they actively block destructive internal swelling that damages tissue and drives depression. This localized swelling is called neuroinflammation. By consistently shutting down this inflammatory process, your brain's biological aging actually decelerates. Over time, this significantly lowers your risk of stroke, severe anxiety, and multimorbidity. So that simple bowl of grains and vegetables, it ultimately acts as a chemical messenger, delivering instructions to your brain to hold inflammation.
Quantum computers promise to solve impossible problems, but current claims of quantum advantage rely on perfect, isolated lab conditions. Now, 2 new research breakthroughs force quantum computing to survive the messy reality of physics and math. First up, the physics. Current quantum chemistry models assume molecules exist in a perfect vacuum, completely isolated from their environment. But in nature, molecules constantly leak energy. Instead of fighting this environmental noise, scientists are using that energy loss, called dissipation, as an active resource to stabilize quantum states. Next, the math. Quantum algorithms are often tested on tiny, isolated logistics networks, but solving a small example proves nothing. The real test is how computational costs explode as the network grows. Finally, proving it at scale. Researchers have developed new methods for massive portfolio optimization problems. By transferring parameters from small tests to massive networks, simulations prove quantum systems keep their speed edge over classical computers. By embracing environmental noise and massive scales, quantum computing is finally transitioning from a fragile experiment into a robust real-world tool.
When overall neighborhood crime drops, why do robberies sometimes spike? It's a targeted trap called the walking ATM phenomenon, where broad statistics hide exactly who is being hunted. Picture a day laborer who just received his weekly wages entirely in physical cash and is now walking home at dusk. Without access to formal banking, he has to carry his entire livelihood in his pocket. If a theft occurs, he faces a brutal double bind. Reaching out to law enforcement carries the immediate, life-altering threat of deportation. Street criminals understand this rational calculation perfectly. They specifically bypass other pedestrians to target this population, because undocumented workers offer guaranteed cash with near zero risk of police involvement. This dynamic explains a massive trend in community data. As undocumented populations grow, neighborhood property crimes and violent assaults actually drop, but robberies uniquely spike. Which brings us back to our day laborer on the street. After his cash is taken, he walks right past the police precinct in total silence, driving the neighborhood's true robbery rate upward without a single report ever being filed.